Section deals with the relationship between exponential equations and log equations. If you notice in yellow, there's a highlighted area that says x equal a to the y is equivalent to y equal log base a of x. That's a function there, not times x. It's a function of x. So y equals the base a log function of x. Mathematically, we say that x equal a to the y power if and only if y equals log base a of x. So that means you can rewrite an exponential expression. If you have x equal a to the y, you can always rewrite that as y equal log base a of x. And also, if y equals log base a of x, we can always rewrite that as x equals a to the y. Now here's a few examples. We have the equation 16 equals 4 to the x. We want to write that in log form. Now you have to notice a couple things about this relationship, and one is that the base of the exponential a is the same base of the log. They always match. So this is going to be a base 4 log. The other thing you have to recognize is the exponent of the exponential. Let's say we have x equal a to the y. Y is the exponent. That y is always opposite the log. It's on the other side of the equal sign. So you're always going to have log base a of the quantity equals that exponent. Well, in this case, x is our exponent. So we're going to have a base 4 log, and that log is going to equal x. And that's what we get. Log base 4 of 16 equals x. Well, you're probably thinking, well, what do I need that for? I know x is 2. But in the next example, we have the equation 80 equals 10 to the x. Now we have no way of algebraically solving that. We can't get x by itself by dividing both sides or taking powers of both sides. But we can solve for x using our log function. We notice that the base is 10, so it's a base 10 log, and that base 10 log will have to equal x. So x will be on the other side of equals. So we rewrite that as log base 10 of 80 equals x. Now you notice there's 3 quantities. There's the base, that goes next to the log. There's the x, it's opposite the log, and that leaves the 80 as the third quantity. Now we have a base 10 log key on our functions. The log function is a scientific function on most scientific calculators. So we can take our scientific calculator and find the base 10 log of 80. We do that, we get 1.903. So we replace log base 10 of 80 with 1.93, and we have a solution for x. X equals 1.903, which is kind of what you'd expect, because in our original equation 80 equals 10 to the x, 10 squared is 100, 10 to the first is 10. We know our answer is going to be between 1 and 2, and it's going to be somewhat close to 2. So our answer of 1.9 makes sense. Here's a few more examples using the log exponential relationship. Our first example is to rewrite 20 equal e to the x in exponential form. And we see that e is our base here. That's the natural base that we talked about in the previous section, 2.718218. And our exponent is x. So we rewrite it as log base e of 20 equals x. Remember, the exponent is always opposite the log with respect to the equal sign. Now we have a log base e of 20 equals x. Well, we have a base e log key on our calculators. And the base e log key uses the notation ln usually for natural log. So to find that on your calculator, you either find the ln key and put in 20, or you hit 20 first on your calculator and then click the ln key. It depends on the type you have. In either case, your answer should be 2.996. In this next example, we're going to rewrite a log expression or log equation in exponential form. Here our log equation is log base 3 of 9 equal x. Now notice the base is 3 and the exponent has to be x because we said the exponent is always opposite the log. So our base is 3 and our exponent is x, so we get 3 to the x. The third quantity always has to be opposite that, so we get 3 to the x equal 9. In our next example, we have natural log of 30 equals x. Now remember, in the previous example we said we use ln to represent natural log or log base e. So I'm going to rewrite that as log base e of 30 equals x. So that makes e our base, and that makes x our exponent on our base. So we rewrite that as e to the x equals 30. Now we're going to take a look at graphing log functions. You're probably thinking, wow, how do I graph log functions? Well, the easy way to graph a log function of the form y equal log base a of x is simply to rewrite it in equivalent exponential form. If a is the base and y is opposite the log, then the exponential form is a to the y equals x. Then what you do is pick the y values first and calculate the matching x values. And then you plot your points and draw a smooth curve through. Let's look at an example. Let's say we want to graph f of x equal log base 4 of 2x. Well, first of all, I'm going to take the f of x out and replace it with y. So this is really y equal log base 4 of 2x. I'm going to rewrite that in exponential form. And that form is 4 to the y power equals 2x. This 4 is our base, and that exponent is always opposite the y, so it's 4 to the y power. So I'm almost where I want to be, but I would rather have x all by itself since I'm going to be calculating x values. So what I do is I take that 4 to the y and I take the 2x and I divide both sides by 2. So you get 4 to the y divided by 2 equals x. Now pick your y values first. When y is 0, 4 to the y is 1, and 1 over 2 is a half. So we get a point 1/2, 0. When y is 1, we get 4 divided by 2, which gives us x equal 2. So we have a point 2,1. When y is 2, 4 squared is 16, and 16 divided by 2 is 8. When y is -1, 4 to the -1 is 1/4. 1/4 divided in half or times a half is 1/8. And when y is -2, 4 to the -2 is 1 over 4 squared or 1/16. 1/16 divided in half or times 1/2 is 1/32. Now we're going to plot those points. We plot the point 1/2, 0. Then we plot the point 2, 1. Then we plot the point 8, 2. And then we plot the point 1/8, -1, and 1/32, -2. Now if you notice, there's no x value that's going to go to 0 or negative. There's no y value we can put in there that'll give us a 0 value of x or a negative value of x. So the y-axis is a vertical asymptote. You get these points, and then you just draw a smooth curve through, and I'll try and show that here. I'm just sort of connecting the points together. And there's your curve with a vertical asymptote at x equals 0.